Okay, this is part 6, but technically some parts of part 5 are pending. I pressed stop recording by mistake. So anyways, life is not perfect, so these things do happen. So let's discuss vector field push forwards. Vector field push forward. Vector field push forward. So there is some subtlety involved in this, right? Suppose is it recording? Yep, it is recording. So suppose f m to n is a smooth map. The question is, can we take x in the vector field of m and get some vector field in n? That's the question from x and f. That's the question, but there are a couple of problems. The problems include, first is f may not be surjective. Then you cannot just define there's no point in f not be surjective. That is fine. If f is not surjective, then how do you even define vector field at that point from f, right? Because there is no point in m that takes it to here. Then yeah, assume f is surjective, then f may not be injective, in the sense that may not be injective. In this case, p1 comma p2 in m, f of p1 equals to f of p2 equals to q in n. Actually, I don't want an enumeration here. Yeah, so once you have f may not be injective, right? So because the problem comes in the fact that x of p1 and x of p2 are tangent vectors at different points on m, but then they match to the same point on n, but then you have different tangent vectors to lift onto f star. I mean, different tangent vectors in m that should be mapped to same tangent vector in n. So that is non-trivial. And if f is injection, then f is an injection. If f is a bijection and that's a smooth map, then basically if it's a diffeomorphism, then we can just define f star x as the push forward without any ambiguity. Let me just take an image from my notes. So okay, so the problem here is that the tangent vectors can be different, and let's attach the image for making that clear. Vector push forward for vector field through the push forward if f So what we do have is that if f is injective, then if f is injective, if f is a diffeomorphism, then we can define f star of x as f star of x of q equals to f star f inverse of q, pushing this vector q, because there is no ambiguity in this. There is a unique tangent vector at every point, going to unique tangent vector at there, and yeah, for all q in n. Yeah, so one way to diffeomorphism is a strong condition to ask, but can we rectify the problem? That we can rectify the problem by demanding that f star p of x of p equals to f star of q of x of q for all p comma q in M, such that f of p equals to f of q. Yeah. Yeah. In this case, if we can define a vector field y on n by y of r equals to f star p of x of p for any p in f inverse of r. Yep. With no ambiguity. So we have the following definition. Start. So we'll define what what we call two vector fields to be F related based on this. So if F into n is a surjective smooth map, then X a vector field of M and Y a vector field in N are called F related if Y of F of P is basically F star P of X of P for all P in M. Yeah. Define two vector fields are F related, where F is a surjective smooth map if the vector field Y is defined on all points of N through this definition F star of P by a push forward near by a if this makes sense. Yep. Yep. We have a very interesting proposition. In fact this is also this is also rarely this is also hard to find. Relatedness vector fields can be hard to exist, but we have a theorem. We have an interesting result for quotient manifold. Manifolds obtained by action by discrete group. Fields can be hard to exist, can be hard to find. They are hard to find. We have an interesting result for question. Yeah. Okay, before stating that, it's not short result. Vector fields if phi and x of n are f related, related if and only if yg f equals to x g sub f for all g in c in n. So what f relatedness does is that when you have n, then um, you're acting this vector field on C infinity n function. Goes with f, where a C infinity m function. This is same as when you act a vector field on C infinity m, C infinity m function. Let's see. For P in M, for P in M, yg of f of P equals to y of f of P times g, the germ of function at f of P. That's how it acts, right? Yeah. Then this equals to, since y is defined by a y is f related to x, implies f equals star P of x of P at acting on f of P. Now this is basically again x of P by definition of P push forward differential g circ f germ of this function, which is equals to x of g circ f at P. Well, so I mean it's not so y acts on C. The meaning of the result is that so y acts on C n to give C infinity m does this even work? If this works, then nope, there is nothing called acts. think I'm gonna work with this. M acted by X. This works for now. So indeed, affiliatedness can be too much to ask. Proposition: if G is a discrete group acting smoothly and properly discontinuously on M, and N equals to M by G, M by G and F M to N is the quotient map, which is also a local diffeomorphism. Suppose X in MFX of M is a G invariant, is G invariant vector field, that is G star P at X of P is equals to X of GP for all G in G, comma P in M. So discrete group acting smoothly and is properly discontinuously on M, comma N equals M quotient G, and F M to N is a quotient map, is also local diffeomorphism. Suppose X is a vector field on M is G invariant vector field, that is G star of X of P. At each point when you push forward this vector field through G, not that G is actually a diffeomorphism, is a smooth. He's not diffeomorphism, but yeah, he's acting smoothly. Then until need a surjection, and what we have is, if it is G invariant, that is G star P of X of P is precisely X of G of P, then there is a vector. We can actually define a f related vector field to x. Yeah, it makes sense, right? Then there is a vector field y in n, which is f related to x. The image, there's a good image for this. Figure loaded. Caption G invariant vector field on n. So intuitively, it's what is happening here is intuitively what's happening here is that the G star takes the takes xp to precisely xgp, but then f identifies these both, p and gp. So there's this sort of f is rejection, cool. This is f may not be injection, but precisely you can actually precisely f relate them because p and gp are identified, and g star of x of p is precisely x of gp. So f star of x of q, x of gp is f star of g star of x of p, which is precisely, since fg is basically f p, then it's just that. Okay, let's see, look at this formally again, and formally first, and then we will be able to talk about it. Proof is that let R equals to f of p equals to f of q, so okay, R equals to f q, f and only f, q is in the same orbit as p, q and p are in the same orbit, that is q equals gp for some g in g. Okay, then x of q equals to x of gp, right? There's some q, that f is matching both, that means p and gp are same, basically q gp is equals to precisely equals to g star x of p. G star of p, fx of p. Yeah. Then then f f star of at q of x of q is equals to f star at q of x of gp, right? And then it is equals to f star at p, f star at q, and then compose with g star at p of x of p. Which is again you're mapping g star p is g star p composed with f star q composed with g star p is precisely the map f star of p, right? Because p is gp. Yeah, f star, but at a different point, which is star at p of x of p. Yeah. This shows that y of f of p equals to f star p of x of p is well defined, and since f is a local diffeomorphism, y is smooth. By abuse of notation, we write y equals to f star x. Yeah. Yeah, so interesting stuff that is enough later. But this is mostly because again, quotient map identifies the group acted points and then g acted points, and then x is a g invariant one. That means that you take x of p at p and you push forward it through g through 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 g to some element of gp. This will give you exactly x of gp, right? Instead of some other vector field, you are defining the action of g star. It's precisely x of gp. Okay, and then there is a danger in thinking too much of intuition or something. I mean, too much geometrically. Yeah. Convince yourself that and through this abstraction, things make sense, right? Yeah. You're sending it forward, and then your gene variance. So it's just G star P of X of P. Q of G star is just a star P of X of P. So these both X of Q and X of P both will go to same tangent vector at f of P of Q, which is R. Mostly because the quotient map the G and P and yeah, mostly because the group action G precisely makes GP shift, and then the vector field at GP is again just to push forward GP. Okay, interesting. I think an examples of this would be make sense, right? So let's start with the examples. They are examples. First example is on S1, I suppose. Vector fields on S1 through quotienting integers on R1. Yeah, there are three examples in fact, and then we'll start the integral curves. Yeah. Yeah, we will not touch the integral curves in this part. Let's just see the three examples and move on. Yeah. Just have some water. It's already 54 minutes. Okay. Consider the vector field x in of R x of P equals to d by dt at P, or x of P equals to just 1. Since it's R, it doesn't make any difference. Yeah. It's not a submanifold, it is R, so they'll coincide. The notion of local writing in terms of bases and itself in R coincide. Coefficients you read off immediately. And this is of course a global frame, d by dt. And so z acts on R as as n t equals to t plus n plus n. So n star p of x of p is simply 1. It's just a constant vector field, so it doesn't matter. Um, then so x is a z invariant vector field on R. It is invariant vector field on R. Another way to see this is to consider gamma of t equals to p plus t, and gamma prime of 0 equals to d by dt vert p, and insert gamma of t equals to p plus n plus t plus n, comma n star gamma prime 0 equals to d by dt vert n plus p. How is n star of gamma's prime 0 is that? Of f o theta o gamma f o gamma f o n, sorry. What does n do? N just changes from basically d by dt of f of n, f of basically it's f of t at t equals to 0. Yeah, I mean tangent vector at p is basically at t equals to 0. Now you are saying d by dt of f of eta, so t of t plus n at t equals to 0. This gives plus n. Yeah, instead of gamma 0 is basically n of gamma prime of 0, right? Yeah, I mean this is precisely that, yeah. So now let f from R to S1 be the quotient map. Then f star p of the vector field that we are considering d dt word p is equals to df1 by dt f1 word underscore f of p plus df2 by dt. So x2 at f of p. Yep. This is now equals to minus sine p to p x2 pp x1 plus x1 pp x2. Wow. Consider now the action of z2 on r2 on r2 we have two vector fields which are z2 invariant if map then t2 summarize this in an image. Okay, so the third example, I probably forgot to resume for some time, but so the third example is this, and yeah, one needs to prove that one needs to show that x, the vector field x, is actually rho invariant or C2 invariant. Um, I fumble a little in the detail. The details there, so I will think through it. I can feel that I'm down in energy mentally. So let me go ahead and finish this statement that hence y equals to q star x will be a smooth vector field on RP2 which will have only one zero, since the antipodal points are identified. Yep. Okay, I need to verify that rho star at x of x is actually x of minus x. How do I verify that? Yeah, for all practical reasons, this lecture is done. Next we'll start integral curves of vector fields. There's one lecture and the last lecture is done. So next lecture we will look at examples for integral curves. Mostly looking for examples of integral curves. We'll comment on the completeness a little, the domain where कहाँ पे exist हो रहा है. Then we'll end with a theorem, and with a set of theorems that will guarantee the existence of these integral curves. Yeah, we just see look at examples, look at its domain wherever they can be defined, and then we'll look at their existence in general existence theorems, and then we're done. So it shouldn't take 2 hours. That I know. So let's see. There is some trouble in looking for rho star at x of x. I'll figure that out. I'll think through it. But I'll for now end the session.